So when we're looking at these exercises, you can see that this one here is a reflection across the x-axis. It's like we're bending across the x-axis to get to the image. This one here is a translation, right? We move to the left and then we slide down. So we got two translations happening. Here we can see that it's a rotation, right? This triangle is rotating. Yeah, I'm not sure. I think it might be 270 counterclockwise. This one here is a rotation across the origin. I think it's 90 degrees clockwise. And then this one here, it's either, right? We can see that it either is a reflection on the y-axis, folding on the y-axis, or it's a translation. We can see it's sliding to the right. What is it, like 4 units? This last one is a reflection on the x-axis because we're bending across the x-axis to get to the image. So those are those exercises there, and now we're supposed to verify congruence using side, side, side. And we can verify that reflection, translations, and rotations of triangles produce congruent triangles, meaning if we do these transformations on a triangle, then the resulting triangle is congruent with the original triangle, right? And we can verify that using side, side, side. Okay, so how are we going to do that? Well, let's go ahead and graph this original triangle, WXY. So that's 3, -7, so that's 2, 3, 4, 5, 6, 7. And then we have 6, -7, so 1, 2, 3 down here. And then we have 6, -2, so that's here, -2 is there. So maybe we could label our figure, so it's W, X, and Y. We can draw our triangle as well, like so. And then we're going to go ahead and draw the transformed triangle, so RST. So R is 2, 0. And then we got 5, 0. 1, 2, 3, 4, 5, 0. And then we got 5, 5. Okay, hold on 1 second. I did 6, -7. Oh no, I graphed this wrong actually. The WXY I graphed wrong. This was 6, -2. 1, 2, 3, 4, 5, 6. Yeah, I graphed it on 5, -2 for the Y. So I don't know how I could fix this, but I'm just gonna go ahead and draw the real one there, and it's gonna go straight down. Sorry about that. So then T is gonna be at 5, 5. So it's 5, 1, 2, 3, 4, 5. Okay, so let me label this triangle. So this is going to be R, S, and T. And then we're going to verify that after the transformation, which is going to be a translation to up and a translation to the left to get to RST, that the triangles are congruent. And we're going to do that by checking to see if the distance from W to Y is the same as the distance from R to T. And also the distance from W to X is the same as R to Y, and the distance from X to Y is the same as S to T, and we're going to do that using the distance formula, right? So we got D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, like so. Right? So we're going to do that for all of the sides, and maybe I could start doing that. So RT would be like so. RT would be 5 minus 2 is 3 squared. 5 minus 0, the y's, is 5, so plus 5 squared. So that's equal to 9, square root of 9 plus 25. So that's equal to square root of 34. Right? And then we're going to double check RT with WY. So I'm going to say WY. Oh no, I shouldn't put the line over it, right? We're talking about the measure of RT and the measure of WY, so no line over it. And so WY would be 6 minus 3, which is 3 squared. And then we have -2 minus a -7 plus -2 minus -7 squared. So this negative makes the 7 a positive, so that equals to square root of 9 plus -2 plus 7 is 5. So it's 5 squared. So that's equal to square root 34 as well. Right? So far so good, right? RT, the hypotenuse, is the same distance as yx. Okay, so let's try the next line. Well, we can obviously tell from the graph that ry is congruent with xy. And we can also tell visually that ty is 5 units and yx is 5 units as well. So we can go ahead and just tell right away that they're congruent. So I'm going to go ahead and make a congruent statement and say triangle XWXY is congruent with triangle RST, and I'm done.